All right, everybody, welcome. Thanks for joining us for the colloquium. Our speaker today is Cheryl Weyant, who's our newest postdoc, having joined us in January, and we're delighted to have her. She came from University of Illinois, and Cheryl is an air quality scientist, and she's conducted pollutant emission measurements from large-scale brick production, oil and gas developments, and residential wood and gas stoves. And she uses pollutant measurements coupled with observations of technology operations and human behavior to understand the impacts of climate change on human health. And while she's here with us, she's going to be working with Liz Moyer, who many of you know, and will be involved in the Crocus project out of Argonne that, again, I think many of you are familiar with. So without further ado, Cheryl, the floor is yours.
Thank you so much. Yeah, thank you. Thank you all for being here. Thank you all for being here online. So I'm going to be talking today about personal exposure to particulate matter. I'm going to be focusing on a deep dive into cooking fuels and how that impacts exposure. But I thought this would be interesting from an urban science perspective, just to kind of like think about particulate matter exposure generally. So the outline of today's talk is going to be an introduction to PM 2.5, definitions, health, and sources. I didn't really know where this group was coming from exactly, so we're going to do a little bit of fun background stuff. And then we're going to dig into household cooking as a pollutant source. And then a research topic on Rwandan exposure, household exposure to PM 2.5, and how the fuels used for cooking impact that exposure. So particulate matter, aerosols, what is this stuff? So this is just really crudely solid and liquid stuff that's just floating around in the air. That's what we're talking about. Often kind of delineated by size. So you hear people talking about total suspended particulate matter and PM 2.5 and PM 10. And these are just particulate matter smaller than a certain size. Here you can see an approximate or kind of relative size PM 10 and PM 2.5 relative to the diameter of a human hair. So it's just small stuff in the air. Why do we care about small stuff in the air? And like the answer is that we breathe it in and it gets lodged in our lungs and it causes health effects. It impacts our breathing. And some of it gets absorbed into our bloodstream and it gets into other parts of our body. And there's a long list of health impacts that are related to particulate matter exposure. We're learning more and more all the time about mental health and asthma, and many, many things are impacted by particulate matter exposure, and even at very low levels of concentration. Why PM 2.5? Why do we delineate this stuff by size? What a weird thing to do. So the reason is that when we look at how people breathe, how much particles get deposited in people's lungs, size matters. So this plot is showing particle diameter on the x-axis and deposition fraction, how much gets stuck in your lungs. And so this big stuff from 1 micrometer to about 100, that just gets stuck in your head. That's your nose. It just gets locked in your nose and you snot it out and not much happens. It's this small stuff that gets caught in your lungs. So this is the particle size fraction in red that gets caught in like the big, open, more cavernous parts of your lungs. That's pretty bad. But this stuff is the really gnarly stuff. So this smaller diameter stuff is the stuff that gets caught in like, I don't know, the like broccoli florets of your lungs, like the really deep parts. And that's the stuff that can cause a lot of the health problems. So we're interested in particles, we're interested in small particles because of their health impacts. And a lot of times I feel like we talk about particles and it's this really abstract thing, like the little circles in the diagram before, but that's not really what we're talking about. So this is a actual picture, a photograph of really, really tiny particles that are freshly emitted from combustion. And what wild little beautiful things. Very complicated, even, I'm just showing this for fun, basically, because I feel like there's something about just having a real understanding of the stuff that we're talking about. So where does this stuff come from? This is a study that was done, that a really complicated study that tried to look at where all this particulate matter is coming from that people breathe from all around the world. It's too complicated, so we're just going to look at the global average part. And one thing we can notice is that most of the particulate matter that we breathe comes from combustion. It's almost all from burning stuff. Wood and charcoal and gasoline and forest fires, all this stuff is a lot of what we're breathing. The rest of it is dust. For the point of this presentation, this 20% section is what's from residential burning. And that, in this case, it's residential coal and biofuel burnings. That's about 20% of outdoor particulate matter breathed is from that source. And when we look at it globally, about half the global population is exposed to PM 2.5 from these solid fuel cooking. That's wood and dung and coal. It's used by almost half of the world's population still. It's to some extent. And this stuff is pretty dangerous because it emits lots and lots of PM 2.5, and people do it every day because it's cooking and it's inside people's houses, where a lot of vulnerable people often, or also, so children, pregnant women, older and vulnerable people, people with asthma, everybody's in their homes. This is a big health concern globally. So people are cooking with these fuels that are really highly emitting, but there are fuels that are lower emitting. For example, charcoal, when it's burned in the home, emits about 85% less PM 2.5 per meal than straight up wood cooking. And a clean burning pellet stove, which we'll talk about a little bit more, but just know that that and liquified petroleum gas, these emit about 99% less PM 2.5 than wood burning. So these low emitting fuels are sometimes referred to as clean fuels, which is not perfectly accurate because fuels depend on how they're burned and they're not perfectly clean, but they produce 99% less emissions of PM 2.5. So we kind of approximate that as clean fuels for the course of this presentation. I forgot to tell you this. Look at this picture is of charcoal cooking, in case you're curious. So it's really exciting. We have these cleaner fuels and they emit so much less PM 2.5, but difficult thing is that emission improvements, so burning something cleaner and producing less particles into your home, doesn't always really translate to an exposure reduction. There's a big gap between what is emitted and then what people breathe. So according to some recent really big studies, a wood to LPG transition could reduce exposure by 32 to 68%. That's quite a bit less than the 99% difference in actual emissions. And the reason for that is that there's continued exposure from other sources. And sometimes, actually very commonly, what happens is that there's not a full transition. So people adopt a new stove, maybe they adopt LPG, they use it for 90% of their cooking, but that 10% that's left really matters a lot. So you end up in the real world with a lot lower reductions. A lot of the measurements so you need to measure exposure. You can't like assume that you're going to get a huge reduction just because somebody changed their fuels or said they did. So you really have to measure this to understand what's really happening and what the impacts are. And the thing is, nearly all measurements of PM 2.5 exposure associated with fuel transitions occurred in rural areas and with wood, dung, and coal as baseline fuels, and many are done as controlled trials. And this is all really good, important science for figuring out what is the potential impact of these fuels, and what is the potential impact, and what is the potential health impacts, but it's not really telling you what the impacts are in the lived experience of many people. For example, a lot of the natural outside of a trial or a program adoption that's happening is happening in urban areas. This plot on the right is showing the percent of population with clean fuels that has grown from 2000 to 2020. There's a much greater use and growth in use in this is lower income countries. There's a much greater use and growth in urban areas compared to, and yet we know very, very little about what the impact of this growth is on people's exposure. There's no other urban measurement in sub-Saharan Africa, and no other urban charcoal with a charcoal baseline. So charcoal baseline is interesting and important because a lot of cities, especially in sub-Saharan Africa, have already gone through a cooking transition where they were using wood in cities and now are using charcoal in cities. So the real difference that we're looking for today in a lot of places is not from the worst fuel, it's from this mid-level polluting fuel, from charcoal to cleaner fuels. And so we really don't know what the impacts are going to be in this case. And then there's also fewer studies that look at exposure outside of an intervention. So interventions often incentivize people to transition to a fuel. And these are this is different than people who actually adopt a fuel. They're different kinds of people, they adopt at different rates. So here we're kind of really asking the question, what is going on in terms of differences in exposure in places where people are adopting kind of naturally. So we look at this by using some data collected in Gisenyi, Rwanda. And my research question is, do urban charcoal users have improved PM 2.5 exposure when they switch to cleaner fuels? So Gisenyi, Rwanda is a large, sprawling African city. It's actually a twin city with Goma in the Congo. Yeah, an urban center where and this site was chosen because it had this pellet program that was going on. So pellets are, a lot of things we can say about pros and cons about pellet stoves. Basically, they're a really high quality combustion stove that tries to use biomass fuels, which is really, really challenging. The stove hasn't really sort of taken off in the popular sense. It's more kind of being tested at this point. So this is, I'd say, a site where this kind of stove was being tested. But they're kind of interesting. It's a gasifier stove. It basically burns these biomass fuels by heating them up and volatilizing all of the fuel into gases and then burning the gases afterwards. So it burns quite cleanly, fascinatingly, most of the time. So the site was selected because this was happening here. And so it was selected, and then the study was originally a randomized control trial, which had a control population and a intervention population, which was differentiated by being targeted for promotion for the pellet stove. In reality, this targeting didn't make a big difference in who adopted and who didn't. And for the sake of my research question, I'm not really interested in whether targeting had an effect. I'm really interested in whether adoption has an effect. So, but that's the kind of context. So in this study, there was repeated measurements at the same households year to year from 2015 to 2020, excluding 2018. And over this time, some things happened in the study population. They were originally a highly charcoal dominant, almost all people use charcoal, all their cooking. After the pellet company arrived, some people adopted pellets. That's this blue area. And the dashed line showed the difference between the intervention and control, which is actually not that large. And then, but at the same time, this LPG gas cooking occurred kind of without any incentives or anticipation. It just kind of happened. So this is, I'm using this data set kind of opportunistically to look at both like what happens to users when they adopt clean stoves, and then what's the difference between these two different types of clean stoves.
Cheryl, just quite for our understanding, LPG, what do you think of that as the same kind of cooking fuel that most US really use inside their house, or is that something?
It's basically a gas fuel. It's actually like, here we use methane. That's in LPG is propane and ethane combo. So it's a little bit of a heavier gas, but it's exactly how you're used to cooking, basically a gas cooking stove. Yeah, good question. And please feel free to ask questions as we go, or yeah, so that's kind of the story. And then, so we have this population and we're measuring their exposure. So exposure, we really talk about what even is exposure. Exposure is basically concentration, and concentration where is a really kind of important and nuanced question that has, people use the term exposure to mean a lot of different measurements. For us here, exposure, I mean a measurement on a person at about breathing level for 24 hours. And that is to, yeah, approximate how much people are breathing as well as we can. They are basically instructed to wear the monitor for their daily events, not trying to change their course of their daily habits at all. And like lay it next to you as you sleep or in bath or whatever. So they would wear these PM 2.5 like on a little backpack, and it's just a pump and a filter, and you collect the mass in the filter, and then you go back to your lab and you weigh the mass. And that's how you measure. There's also a carbon monoxide component with a real-time electrochemical carbon monoxide sensor that's measuring and yeah, the 24-hour sample. In addition to exposure measuring on a person, a subset of households also had measurements in their kitchen or in their, what we call the cooking area measurement, because what is a kitchen is kind of an ambiguous thing. We tried, you know, having people tell us whether they cook inside or outside or what kind of environment. It's all very confusing because people are cooking in very different environments, sometimes in like a very enclosed kitchen and sometimes basically open air, and then in kind of everything in between. So there's a measurement also kind of about a meter from the cooking, wherever the cooking is, using the same sensors. And in addition, there's some ambient monitoring. This is this diagram is showing the households that were measured in the study. You could tell it's a fairly tight region that was measured, about a mile square, and in a center-ish area, which was selected for convenience, there was monitoring of PM 2.5 and CO for some of the years. Okay, this is a kind of complicated piece. what fuels do people use is not really easy to define. So people are often using mixtures of fuels. So we had to come up with a couple definitions to figure out how to sort of like group people in meaningful ways. So all people were asked, what percentage of cooking do you do with charcoal in the past 30 days? What percentage of cooking do you do with LPG? And we basically took these answers and said, whichever number is biggest, we're going to call this your primary fuel. And one benefit of this question is that absolutely every person in the study was asked this. So we have this data for like the full set, which is pretty critical. And second question or second way of trying to group people is this exclusive fuel. So we said, what fuel were you using on the day of measurement? And then we only included households that were using a single fuel. So these two measurements are kind of trying to bound a problem here. And the problem is that we are measuring exposure on one day, but what we want is the representation of the fuels they use on, for an extended period of time. So we have this kind of like time disconnect problem. And to kind of, bound the problem, I said, okay, we're going to just do primary fuels, which is going to be air a little bit high because some people will say they're LPG users, but actually will use charcoal on the day we measure them, but they're still in this category, right? So this category isn't perfectly delineated by what people actually did. The exclusive fuel is delineated by what people did, but not by what their normal fuel ratios are. So anyway, that was clear. So this part is kind of boring, but I think we have to get through it because it's hard to understand without understanding the sample population, and it's complicated. So this is bar chart showing our samples for PM 2.5 exposure measurements in 2005, 2015, 2019. You can see that, well, as we showed before, most people were charcoal users early on. In our sample set, there's more pellet and LPG users in our sample set later in the data. And there's about 150 households in each year. The intention was to measure the same households over and over again, but I think only about 80 households were in every year, and the rest were sampled from larger populations. So it's kind of a non-perfect panel. For exclusive fuel users, excluding people who use multiple fuels in that day. So it's a smaller number of people. It's about 100 people, 100 households per year were in that exclusive group. For cooking area concentrations, this was already a subset. So that's about 50 households a year. And for cooking area concentrations for users of exclusive fuel, this becomes a pretty small population. This is, I think, about 40 households a year. For carbon monoxide, I kind of used a larger study that was happening, like the same study happening in parallel. They measured a lot of CO. My primary interest here isn't carbon monoxide, but carbon monoxide is co-emitted with particulate matter. It's another combustion product. It's not perfectly correlated with PM 2.5, but it's kind of an indicator of combustion happened here. Okay. And I have a pretty large sample set of carbon monoxide samples. About I think 1,400 in the 2015, 2019, about 150 in the other years. The other samples are, other than exposure, the rest of the CO was just done in parallel with the people. It's about the same number of people in different populations. Phew. This is a complicated study with just a lot of different sample sizes, which is confusing. So let me know if, anyway, that comes up again. So for the statistical analysis, I did two basic things. I looked at all the data with no corrections and just said, well, what do we get? And then that's interesting, but we know that there are some biases in our sample collection. And so I also did a couple random effects models to try to correct these biases, account for the fact that we have the same households measured over again. And the covariates include acid wealth, uses a kerosene lantern for lighting, burns trash, burns fuel at the workplace, cooks outside, and some dummy variables for each sampling year. I ran 8 models with dependent variables, CO and PM2.5, exposure and cooking area concentrations, and primary exclusive fuels. So it's a kind of a lot. I'm going to try to synthesize it and make it make sense. Let's just look at the data. Okay, this is just the plain data set as is measurements from all sample years, just kind of like grouped together in one big block. What we see here is PM 2.5 on the x-axis and concentration, and so the first thing we noted is that charcoal users had higher exposures than either pellets or LPG. Pellets and LPG have similar distribution of exposures. So that's interesting. Okay, I'm kind of like seeing a little bit of a trend here. Other things to notice about this kind of data is that, this is on a log scale. This is a strongly log normal distribution, which is typical of this kind of measurements. You end up with almost always some people with some wacky high measurements. So that's that's just what the nature of what exposure measurements look like. And there's also a lot of variability, and that's also typical of these kinds of measurements. So a lot of overlap. There's people who cook with charcoal who have, as low as 10 micrograms per meter cube, and people who cook with LPG has almost 1,000. So there's a huge distribution going on here. When we use the random effects models to try to sort of correct for some of the biases that exist in our data, we see that on this plot on the right, that there's kind of a smaller effect that emerges. So the bars on the left here show the geometric mean and the 95% confidence interval for the measurements of charcoal, pellets, and LPG. The same stuff we saw on the previous slide, right? Just kind of oriented differently. And the random effects model is showing the differences when we kind of adjust some of these covariates. And we see a much lower effect size, and we see no significance for LPG and very little for pellets. So, well, that's interesting. I wonder what's going on there. And so I dug in a little bit. I said, okay, what's going on in my model? So what's kind of happening is that these dummy variables for year are strongly impacting what's the model. So, okay. So I looked at that. So it says, okay, well, let's look at what are the effects year by year. So, okay. So here I'm showing the data now delineated by the different sampling years. So in white, the white dots are the mean exposures of the charcoal users. The triangles are the LPG users, and the triangles are the primary pellet users. Just forget the exclusive stuff here. We'll just talk about that later. And the lines are just kind of helping your eyes see the difference, right? So there's this kind of year-to-year effect. Well, that's what I'm calling it, where you have really high or higher exposures in the general population in the early years of the study, and lower exposures in the later part of the study, particularly in 2019. And that's kind of a problem for us a little bit in the way that we sample this data, because in 2015, we had almost no clean fuel users, and in 2019, that's when most of our sample was. And so what's going on is that we're kind of probably over projecting the significance of the clean fuels if we use kind of a pool sample, because there's this variation going on between year to year. And I'm pretty sure it's true. I did some checking. The same pattern was observed for just exclusive charcoal users. So the trend is not influenced by clean fuel use. The trends were also not explained by any variations in household selection. And it was observed in the subset that was measured in all years. One thing kind of interesting here to note is these fluctuations in the kind of exposures from year to year are quite large relative to the effect size we're seeing in clean fuels. I think I said, yeah, 4.5 times greater than this clean fuel effect. So something's going on here that's impacting people's exposure more than their clean fuels, it seems like. So yeah, some variable is associated with this year-to-year fluctuations. I don't really know what it is. My study, we don't know the answer to what was causing this. We do know a couple of things. It's not likely background. I have some background measurements and it's quite a lot lower to this, and the trend doesn't match what I'm seeing here. It's also probably not seasonality, and it's probably also not some general clean fuel related improvements that's like decreasing the concentration in the whole population, because we don't see that with CO. My theory is that it could be due to variations in charcoal quality that's changing the emission characteristics for the population. But if you have any other cool ideas, I'd love to hear it. So kind of coming back to the main question, we're looking at, clean fuels and their impact, clean fuels and what their exposure was impacting. So, what we're basically seeing is that clean fuels had about a 20 microgram per meter lower PM 2.5 exposure with low or no significance and a lot of uncertainty. But we have some more information we can look at to try to kind of better understand the story. We have exclusive fuel users, which help us ask the question, is stove stacking the reason why maybe exposures aren't more strongly influenced? We have carbon monoxide measurements, which help us ask, is there evidence that fuels influence cooking emission exposures? And there's cooking area concentrations, which help us ask the question, do the fuels influence indoor or cooking concentration? So let's look at these other kind of aspects of our data set. So for exclusive users, we see that they had, this plot here is showing one similar that we saw earlier. And for the sake of this question, we're asking, are primary fuels higher or lower than exclusive fuels? And we can see that for LPG, at least, there's kind of a decline. So using more LPG in your household seems to lower your exposure. So that makes sense. The same isn't really true for pellets, which is interesting. I have some theories about that. So in general, the exclusive fuel data seems to indicate that, okay, there's probably an effect here, at least for LPG, such that if you use it more, you get more of an effect. Okay, that's information. For the carbon monoxide measurements, is there evidence that fuels influence the cooking emission exposure? And the answer is hands down, yes. There's a huge effect for CO. We get large reductions in all of our models from pellets and LPG, a little bit lower for LPG use. And that's both like really exciting news, but also notice that the exposures are all for the entire population are quite low from a health perspective. So this is mostly an indication that, okay, there's something about this relationship between cooking and cooking with clean fuels and exposure to combustion byproducts. That's what this CO, I think, is mostly telling us. The cooking area concentrations ask, do the fuels influence, do they influence the area where you're cooking? If they don't do that, you're pretty sure we're not really seeing anything, right? So this seems significant in the pooled sample, but not after model correction. Though there is, remember that this is one of our smaller sample sets. So we're kind of seeing a signal, but not a lot of significance. But the same basic story for LPG as with our exposure data. What we see is that primary use of LPG and pellets reduced exposure a similar amount, but we have some more evidence from our other sources that LPG might be kind of having a bigger effect. So exclusive use lowered LPG exposures a little bit more. CO showed that clean fuels reduced reduced exposure, which was greater for LPG, and the cooking area concentrations tended to be a bit lower for LPG users. So I think the whole of the measurements suggest that there's a small but uncertain reduction in PM 2.5 exposure for both use of pellets and LPG, but the case is a bit stronger for LPG. So relative to other literature, step back, we dug really deep into this one data set, like what does it mean in relation to anything else? So this plot is showing our data, our kind of like model corrected observations relative to a series of other studies. I'm showing our data twice because the one on the left here is in the arithmetic mean because some people reported their studies that way, and the ones on the right are the geometric mean because some studies report their data that way. So I am comparing both. So on this like furthest two bars on the left, we're seeing our study compared to the closest like urban charcoal measurements I could find, which is a peri-urban measurements done in outside of Accra, Ghana. And what we see is kind of very different from what there's, I mean, we're seeing a very small effect. We're seeing about a 11% reduction in exposure, and they're seeing about a 20% reduction. We're seeing very different absolute exposures, and they're seeing much, much higher. So that's kind of interesting. The other thing that we're seeing is that, you know, relative to a series of studies done in rural wood as a baseline fuel, our measurements are quite high, our reductions are quite low, and even kind of notably, our LPG exposures, our cleanest fuel user exposures are much higher than even wood fuel users in rural areas. So kind of note that our exposures are high, our differences are small compared to other studies. And the kind of comparison to other observations shows a fairly similar story. Our exposures are high, our reductions are small compared to most of the region. So I want to talk a little bit about the actual magnitude of the concentrations. So for everybody in our population is exposed to dangerous levels of PM 2.5 exposure. The WHO's like recommended limit is 5 micrograms per meter cube, and that's like not even on our scale. The interim level is 35 micrograms per meter, and we're hardly meeting that. Even the cleanest fuel users are not breathing clean air in this situation. Oh yeah, and to put that in another perspective, right now we're arguing about the difference between 12 and 9 micrograms per meter cube, which is again not even on the scale of what we're talking about here. So another kind of piece of this is that, so we measured background or ambient concentrations, and even these are quite high. So when you're not even in a household, you're not, maybe your neighbor's not even cooking charcoal, you're still, the exposures that we're observing here are very high, and you know, quite bad for your health. But I do want to talk about like the way, so you know, there's a couple ways to think about it. It's like, okay, well, we didn't see a huge reduction, but we said an 11% reduction. Like that's not nothing. Like, okay, the issue here is that the relationship between constant exposure and health is nonlinear. So a 11% reduction in exposure results in about a 4% reduction in this case, lower respiratory infections. And the same is true for many other diseases, is that this, I don't know why we see this kind of relationship, but we do, where you have to make quite large reductions in exposure, especially at the high end, just to see reductions in health outcomes. That's just some context. So in conclusion, so our exposure reductions attributable to clean fuels are kind of uncertain. Our best guess right now is that there's about a 20 microgram per meter cube reduction when charcoal users switch to clean fuels. And this reduction was small relative to yearly fluctuations in exposure, and it was small relative to reductions from wood in rural areas. And notably, everybody's exposures remained high, well above safe levels. So I guess cooking reductions is a required but not sufficient means to achieve healthy air quality. And in this case, it might not even be the most influential source to address, particularly and perhaps in areas that use charcoal for cooking. So that's what I have for today. I want to thank my co-authors very, very much. I was not on site for this data collection. I was the analyst, not the site collection. So a lot of people put in enormous hard work to make this study happen. Thank you.
Yeah. So thank you for this presentation. This is a really interesting topic, and I can see the significance, as you said, of where most of the research has been in rural settings and in comparison to wood, and that's not really the most relevant question, especially in the context of urbanization. So this is really, really interesting. I wondered if you could just explain again what was the reasoning for surveying primary use instead of only using the single use, because I wondered when I saw that if you were going to maybe be comparing to some long-term household effects or something, but it seems like your question was mostly what is the effect on exposure based on the fuel that is used? So why wouldn't you just use the single use measure?
One reason is that this question about what is the primary fuel people are using is like the most common question that it's basically how the World Bank and everybody is counting this question. So yeah, so if you want to say, if you're looking at this measure or people using clean fuels and this is how they're measuring it, I kind of wanted something that could relate to that. Yeah, so good question.
Yeah, and then now will you remind me, I'm trying to picture your results again. It sounds like I'm wondering if your results were generally more significant for the primary use sample versus the single use sample. I'm trying to remember what it looked like.
It kind of depends on exactly what you're talking about, but I think was it more like I think for LPG it was more significant for exposure, but again it's kind of hard because the sample sizes are smaller.
Of course, yeah.
And so it's kind of hard. It's a little bit apples and oranges to just like say is one significant.
Yeah. Okay, that helps though. Thank you.
Can you go back to the slide pretty early on where you showed the difference in urban and rural uptake of clean fuel technology? Because so you framed the beginning of this talk as like it's important to study clean fuel adoption, particularly in an urban context, because we can see that a lot of the clean fuel adoption is actually happening in urban areas. So I had an initial question about why that's the case, if it is more an access versus policy piece. But then fast forward to your findings, which are kind of suggest like actually changing fuel matters a lot more in these rural settings than it does in the urban setting. And so it kind of, and almost like flipped your framing in an interesting way, where you were saying like, there's reason to study it in the urban, but actually we don't find as much of an effect in the urban as we do. So,
yeah, well, I think it's important because this is kind of also some context is that there's a lot of sort of projecting. What would clean fuels do if everybody switched to clean fuels? And the thing is, right now we're using most of these rural estimates to gauge what the effect would be on a global scale. And I think like, wait a minute, that's probably really overestimating. And if most people are adopting these other contexts. So I don't know if I quite got to it here.
but so then, can you explain this graph and if it's like is it access to clean fuels that's driving this difference versus
It's mostly
policy?
I think it's mostly access.
Okay.
It's so LPG is mostly like just small canisters that have to be like moved by truck. So they're usually bottled in urban areas and then, or being moved around the country. And yeah, there's just there's just greater access in urban areas. I think that's most generally true.
Can I chip in? The question she asked about difference between urban and rural divide. So I'm taking this course on human behavior and energy policy by Professor Kim Folske. And she discussed one study in Africa, rural community in Africa, why they are using non-clean fuel.
Yeah.
And it came out that the food tastes better when it comes to non-clean cooking fuel. And they think that LPG or any other alternative mean is a threat to their culture. So these are two
Yeah.
prominent reasons.
That is like a thing that exists and it comes up in the literature. It does also seem to be largely an economic factor though. So I wouldn't say that's not a factor, but when people have access or have subsidized fuels, they often use them in most places in the world. Yeah.
Cheryl, you've been cautious to stay very close to your data and your study.
Yeah.
Which is great, but I wonder if we could get you to just extrapolate a little bit. So I'm trying to imagine why it might be that the effects are so much smaller than I guess a lot of people would have expected. And is what we should infer is that in urban areas, there's just so many sources of pollution that people are exposed to in their daily life that changing their cooking fuel at home just doesn't result in a huge proportionate decline. Is that it?
Yeah, I mean, there's other sources. Yeah, I think there's just a lot going on in the city that may not be the biggest source that we're exposed to. Whereas in rural areas, it almost always is the biggest major source that people are exposed to. And so it's kind of the assumption in some ways.
And so what else would, like, if you had to then guess, say, oh, it turns out it's not the cooking fuel used at home, are there other like modifiable sources of pollution, or is it just like, gee, we're kind of screwed because cities have lots of cars and factories and whatever else is generating this pollution, and it's not going to be so easy to change?
Maybe, so there's, if a lot of the source is the charcoal, it's not to say you can't improve the charcoal itself. You can improve the charcoal quality, maybe you can also improve the way the charcoal is cooked without necessarily changing fuels. I'm not saying that's like the best option for people, but that's also, it may reduce emissions or exposure about this much to change qualities of the charcoal fuel. It's possible that even makes a bigger difference. So it's just so much we don't know. Like, it's sort of frustrating for me to have this study be done, maybe that a rural study is done. It's like, well, there's so much else going on here in this context that is required to really understand even this part of the story that we don't know. So they didn't study how close people were to roads and other sources of pollution. So I don't know.
My question is kind of a little bit related to these prior ones. There seems to be like an assumption that people use the same amount of fuel, they just use different kinds of fuel. Is that actually true? Or is there like a Jevons paradox thing here where, like people have access to the better fuel and so they're just cooking more?
Yeah, so there is like this sense of like when people are not, there's an energy poverty thing happening too, where people maybe are restricting how much they cook to save money. So when people have more access or more money, they do sometimes cook more. This is probably not as big of an effect here for this particular question. Just because the differences in emissions are so drastically big that a slight difference in like the amount that you cook with LPG is just not a huge difference. But that does happen.
Could you give us a sense of the economic difference for families to procure these kind of fuels? Like, about how much would it be for me to cook a meal with charcoal versus with LPG?
So not that different. Actually, the thing, it's just a barrier to access because you have to pay a bunch of money up front for the LPG. It's actually on a per meal basis, not that different in this context.
Why do you have to pay a lot of money up front?
You just need to buy a month's worth at a time because your tank is such
I
that you have,
see.
that's just the scale of the
Got
object,
it,
whereas
got it.
charcoal you could buy on like almost a meal by meal basis. There's an economic term for this this escaped me, as somebody else knows.
It's okay, I don't know it either.
So, but yeah, so there are people who try, who do a kind of pay-as-you-go type model for LPG, and that's interesting to see if they can overcome that barrier. Just, it's an access barrier more than it is a money barrier in urban areas where people are already paying for fuel.
See about the weirdness of the year-over-year variability you saw in that big factor, and I guess I'm just curious, like, not that you can go back and redo the study, like, what data would you have liked to have seen to investigate that kind of question, because it was so different, and like, what do you wish you had?
I wish I had more like, dispersed background measurements in different parts of the community. So like, I don't know if my background measurements, I don't know what they represent really. It's very hard to like, it's like, are people really just exposed to their neighbors? Is this something happening in a larger scale? So yeah, there's kind of a gap there between that I don't know, that would be helpful.
Do you have, I mean, so you have this map of where the respondents are. Can you look at their proximity, like what their neighbor is burning and bring that in? And then also you said you don't have measures of like distance to roads, but if you have their location, you could.
Maybe I think there's something to remember here. This is very kind of noisy data set already. Proximity to neighbors is probably not truly possible because these people were not measured all on the same exact day. So you don't necessarily, I don't have the data about what their neighbor was doing on that day. Yeah.
Question, it's kind of like this comment about this idea that the food tastes different with the different fuels. I'm wondering, I know this was outside of your study, but if the same team is thinking about further stuff, or if you know of studies that have looked at the perception of the impact on the air quality of changing, from one, I mean,
Yeah.
just like personally, a couple times a year that I spend an evening around a campfire, like I feel it the next day, and so I'm just wondering whether that kind of perception maybe plays a role in people's decision making at all.
Yeah, I think in most places in the world at this point, there's a sense that cooking on traditional fuels is bad and cooking on LPG is better for your health or electricity. I think that's broadly, I'd say, understood and acknowledged. It's just financially hard. It's financially and logistically really, really hard. It's not that people there are some people with preferences, but for the vast majority of people, it's an economic access problem.
Yeah, I was just wondering, like, even looking at the line for like urban populations, like I know Latin America is the most urbanized region in the world. And also like technologies are adapted very well there. Just like lots of different studies and different things. And when I was growing up there in the 2000s, I remember this was a conversation that was happening. So I'm just curious if maybe that's part of the literature you've looked at, or if studies have been done there and maybe how they might compare to this.
Yeah, so what country are you talking?
Honduras specifically,
Honduras, okay.
small one.
Yeah, I think there's been a lot of, so in certain parts of Latin America, there's been like huge, I think Ecuador, Peru, I can't remember all the countries, I'm very sorry. But there's some countries that have made a massive transition to LPG cooking in the past like 20 years, from like 0 to 100, and that's pretty fascinating. In other places, there's been also a focus on very clean wood fuel cooking. In Latin, it's kind of a mix of programs and perspectives that happen there. I think maybe there's a preference for a kind of cooking in some parts of Latin America where fuel is preferred. But yeah, so I'm kind of interested in Africa because it's so understudied and it's like the transition happening now in real time and we can watch it. So yeah, but there's a lot of variability in countries around the world and where they're kind of at on this spectrum.
I feel like in the United States, there's this conversation around climate change and what like individual households can do that people often argue is obscuring the fact that the biggest polluters are corporations and industry. And I'm kind of thinking about that in context of your findings and wondering if like, one of the takeaways of your findings is sort of actually the cooking fuel transition is individualizing this idea of environmental change, but actually doesn't make that much of a difference. And so if we want to improve our environments, then we need to look beyond that. Or, I don't know, that's sort of extrapolating across contexts, but like is part of what your findings showing that like clean fuel transitions maybe aren't the solution to improving population health.
I think they're part of the solution. They're just like not the whole solution, you know, or maybe, yeah. But it's kind of interesting. I think, you know, kind of from a political or ethical perspective, there's like a lot of pushback on like, don't blame poor people for their pollution. This isn't fair, right? But at the same time, in a lot of places, this is the major source of pollution. So it's kind of a complicated. But that's, you kind of have to find a way to work within that context, I guess. Maybe, yeah, I don't know. That's what it made me think. I'm not quite sure if there was a question. Oh, no.
Related, sorry, did someone else? Related to this question, I'm obviously totally ignorant of this whole domain, but I find it fascinating. Is there a like climate change and greenhouse gas like element to this debate? Because obviously like methane and propane and butane and all those are fossil fuels.
Yeah, so interesting. One of the rare cases where switching to a fossil fuel generally produces lower climate pollutants, and it's primarily because when you burn with wood, for example, you're producing, well, first of all, you're producing the carbon dioxide, and some of that is, you know, you know, what's the word? Like some of that counts and some of that goes back to the forest. There's a word for that that's escaped me. But anyway, even if you don't count that, like the combustion is so bad that you're producing a lot of other gases and particles that are having climate impacts as well. So on balance, people are trying to assess this question, you know, with life cycle analysis and everything. And it's looking like actually cooking with LPG because of the efficiency and the reduction of other climate pollutants could have a net benefit. Fascinating. But, you know, and then the other debate is people don't like that. Don't like that conclusion. So, yeah.
Kind of touching on what Lydia said about having like a larger impact versus, you know, individualized impact in the households, but maybe like your future research incorporate like direct health impacts to the people who are cooking, because I can imagine them cooking with just charcoal in like an enclosed area versus the LPG.
Yeah.
And so even though it might not have an overall like climate impact, it might not have a direct health impact.
Yeah, so there's a huge amount of studies that look at this particular question, which is, it's fascinating. Less so in the urban spaces because, well, I guess if you see very little difference in exposure, you kind of are very unlikely to see the differences in health, even if they exist. You just need an enormous study size. But they have found things in these rural studies. Switching improves some. They do a lot with pregnancy trajectories in young ladies, where they do see some impact, but much actually less than anticipated. So that's kind of an interesting area of research of why kind of smaller impacts or some impacts are not being found that were expected to be found with after there was a large reduction in exposure. So there's kind of a curious, yeah, there's a lot of research out there about that topic.
won't. Thanks, Cheryl.